Question 6. A student determined the relative molecular mass m of unknown volatile liquid Y in experiment as shown in figure 5. Student used a hypodermic syringe to inject a sample of liquid Y into a gas syringe in oven. At the temperature of the oven, liquid Y vaporized. Student results shown in table 2. There's table 2. Just find the term relative molecular mass. And then there's another part. But the first part, relative molecular mass. So relative molecular mass, average mass of one molecule, right? Average mass of one molecule. So let me type it up. Is the average mass of one molecule on a scale where an atom of carbon 12 is 12. Average mass of one molecule on a scale when atom of carbon 12 is 12. And then it says your experimental results in table 2 determine the relative molecular mass of Y. Well, we're going to use PV equals nRT, ideal gas equation. And in order to find molecular mass, we need the moles. Moles of the mass of MR. So we need to rearrange it to get N equals PV divided by RT. PV divided by RT. So pressure in pascals. So N equals pressure in pascals so pressure in pascals is 102,000 pascals. Volume 85 centimeters cubed. We don't want it in that, we want it in, so we need to times by 1 times by 10 to the power minus 6 dm cubed. Meters cubed actually, and then we want R, which is 8.31, times by temperature, which is 98.1 degrees Celsius, but we need it in Kelvin, so we need to add 273. 98.1 plus 273. Let's work that out, and then we can carry on from there. .81 times by 10 to the power minus 3. Now that's the mole. What we're trying to find the MR, relative molecular mass MR. So we need to know the mass, and to find out the mass of liquid Y, we're just going to subtract these two. So mass equals 10.91 minus 10.70, which will give me 0.21 grams. That's the mass of Y. Therefore, we know moles equals mass of MR, classic GC equation. So therefore, MR equals mass divided by moles. MR is equal to 0.21 divided by 2.81 times by 10 to the power minus 3. 0.21 divided by 2.81 times by 10 to the power minus 3. MR of 74.7. I wonder if you would allow 75, but 74.7 to 3 significant figures. And then 6.2, some of the liquid injected did not evaporate because it dripped into the gas syringe nozzle outside the oven. Explain how this would affect the value of MR of Y calculated from experimental results. Think about it. We're injecting a sample of liquid Y into gas syringe and oven, then at temperature oven, liquid Y would vaporize. We're injecting it into a gas syringe in an oven. So if it dripped into the gas syringe nozzle outside the oven, it's not going in the oven, how would this affect the value of the MR value of Y? Some liquid did not evaporate, dripped into the gas nozzle outside the volume. Well, we're going to have a lower MR value. We're going to have a lower volume recorded. Lower volume of MR recorded. Lower volume recorded. Hence, the actual value of MR, the MR value would be greater, because we need to consider that. And then if the liquid injected that did not evaporate actually went into the oven, then the MR value would be greater than the real MR. Would be greater. This negatively affects the results. Lower volume recorded because dripping into the gas syringe nozzle outside the oven, hence the MR value would be greater than the actual value we just got. And that's the end of question 6.